Right, we begin by finding all invariance points of these quadratic iterations. But first, again, it's always a good practice to note this down. Initial value. After one iteration, you will get this. And then the next iteration is where you put this first iteration and push it into the Z. So that means that we push the first iterations into Z. Okay, see that? It's just like Z squared plus 1 over 4. And the next one means that I push Z squared plus 1 over 4. Remember that this is actually second iterations. Square plus 1 over 4, and you push a whole lot of this into this function. So this is again like a big Z square plus 1 over 4. Now stop there. And so to find the invariant points, we set Z equals to Z squared plus 1 over 4. See the initial value equated to the first term, or the first iterations. And so by multiplying cross by 4 and rearranging this, you get this quadratic equations. And using the formula, you should be able to see this is 4 plus minus 16 minus 16, b squared minus 4ac, and 2a, so this is 8. So you end up with half. So that means your invariance, there's only one, is the value of half. Now they ask you to perform a 4 iteration, determine whether that complex number belongs to a Julia set. I don't really care whether it's Julia set or Mandelbrot and so on. All you need to know is to do the calculations showing that that particular starting value, this one right here, actually as long as it does not diverge, that's a good sign, right? So here what we do is we let the Z naught be negative half plus I, and our aim is to want to find out what is Z1. And actually it's pretty straightforward, because we'll be doing this one square and then plus 104, you see. And here we might use the calculator to help us a bit. And to do that, we enter, make sure it's in complex mode, and then make sure you enter the right value. This is negative, so I want to enter 1 over 2 and plus I here. Now taking this value as the initial values, and so I'm going to take the answer square. I'm going to actually doing the function itself. So the outcome is negative half minus I. So that means if I expand this and rearrange this, I will get negative half minus I. And now this Z2 would be, which means we calculate this Z1 squared plus 1 over 4, and we push this value from here into this into the calculation. And you can check the calculator once, just type equal, I'll get the next one. So the next one means I'm going to get negative half plus I, and we keep repeating this. You should be able to show that this is what Z2 square plus 1 over 4. Using these values, you would get negative half minus I, and also Z4 would be taking Z3 power square plus 1 over 4. Z3 of course is this negative half minus I, and then you have this plus I. So clearly you can see that this initial values, this negative half plus I, is actually a 2 cycle. It repeats itself every alternate iterations. So therefore this value is a 2 cycle, and so it's in the Julia set because it is not divergent. Okay, so I hope you try the other questions, and all the best.